Good morning, my math friends. So today we're going to be looking at three different types of exponent problems using our laws of exponents. And the title of the worksheet is Exponent Warmup 2 Notebook. So if you want to pause for a minute to get that out, have that sheet handy, you can do so now. So we're going to get started here on the first example. So one of the things that I want to show you here is that we have 2 to the power of negative 2 plus 2 to the power of negative 1 in parentheses, and then raised to the negative second power. Notice how we have two terms in here. When we have two terms separated by either a plus or a minus sign, we have to take on the problem using PEMDAS. So remember PEMDAS, parentheses, exponents, multiplication, division, and then addition, subtraction. So we're going to use that here. So parentheses first. I'm going to do inside the parentheses. So what I have inside the parentheses is 2 to the negative second power plus 2 to the negative first power. I first need to try and get this down to one term. So when I do that, I'm going to think about what happens when I have a negative exponent. I take a reciprocal of the base, and I'm going to change the exponent from a negative 2 to a positive 2. And I'm going to do the same thing for this term. 2 to the negative first is like saying 1 divided by 2 to the positive first. So now I want to think about what is 1 over 2 squared. That would give me 1/4. And 1 over 2 to the first is 1/2. All this, again, raised to the negative second power. Now I need to think about combining these. So when I add fractions, I need a common denominator. My common denominator is 4. So I'm going to change that 1/2 to 2 over 4. I'm going to add it to the 1 over 4. Raise all this to the negative second power. I'm going to get 3 over 4 to the negative second power. So now we have to think about what happens with this. I have a negative exponent, which means I can take a reciprocal of the base. My base is 3 over 4. The reciprocal would be 4 over 3. I can raise this now to the second power, and now it's like saying 4 squared over 3 squared. So that becomes 16 over 9, and we can call this one done. So again, just kind of recapping, we had two terms inside the parentheses separated by a plus. We're going to work inside the parentheses first, so parentheses first, combine it to one term. Then we do our exponents. We're going to raise to the power. So that negative, we're going to take the reciprocal of the base and then raise both of these to the power of 2. The next example is a little bit different, and we can kind of take this on two ways. We can follow PEMDAS here, and or we can raise a power to a power. So because this is a multiplication and not an addition or subtraction, I could raise this product to a power using our laws of exponents. So when we do that, we multiply the exponents, we keep the base the same. So we get 4, negative 2 times negative 1 is a positive 2, and 5 is my base. Negative 1 times negative 1 is a positive 1. So this becomes 16 times 5, which is 80. And we can call this one done. If we wanted, we could have taken this one on a different way. We could have followed PEMDAS. So if we wanted to do it another way, using PEMDAS, we can do inside the parentheses first. This would be 1 over 16. This would be 1 over 5. 16 times 5 is going to give me 80, so we have 1 over 80 to the negative first power. And when we rewrite that with a positive exponent, this negative tells me to take the reciprocal of the base. So 1 over 80 becomes 80 over 1, or just 80 to the first power. So you can see we get the same result doing it two different ways. The last problem here number 3, we have 3x cubed plus 9x squared, all divided by 3x to the negative first. I think probably the easiest thing to do here is to separate this into two fractions. So when we have either a plus or a minus on the numerator, so when we have more than one term separated by a positive or a negative here, we can break this into two fractions. So I can rewrite this as 3x cubed and then my 9x squared, and both of these are going to be divided by 3x to the negative first. And then we can simplify just like that. So if we kind of think about over here, the 3's are going to cancel. And what I'm left with is x to the third divided by x to the negative first. So this is really like saying x cubed times x, or x to the fourth. And on this side, I know 9 divided by 3 is going to give me 3. So this is like saying 3x squared over x to the negative first, or 3x squared times x, or 3x cubed. So we have x to the fourth plus 3x cubed, which would be our final answer. And again, there's more than one way to do this, but I think that this is probably the most straightforward way to think about it, is to break this up into two fractions. You can only do that if the numerator is separated by a plus or a minus between those two terms. Okay, that's it for now. Thanks, guys.